from the sun blows outward at 1,000,000 miles per hour and creates this bubble. And as you can see in the animation, that the two Voyager spacecraft are in the outermost layer of that bubble, heading toward interstellar space, which is the bright region outside. The mission started many years ago. In fact, the spacecraft were launched in 1977. That was a very special year when the planets, outer planets, were lined up so a single spacecraft could fly by all four: Jupiter, Saturn, Uranus, and Neptune. That's called the Grand Tour. But we didn't start out with that as the ultimate goal. We started out with a more near-term goal of just getting to Saturn, a 4-year mission to Saturn. Both spacecraft, as you can see in the graphic, flew by Jupiter, got a boost on the way to Saturn. Voyager 1 went behind the rings and therefore went up out of the plane of the planets. No more planetary encounters, but when it succeeded in its mission, that allowed us to keep Voyager 2 in the plane of the planets to continue on to Uranus, which is 19 times as far from the sun as Earth, and then finally on to Neptune, where it over the pole and downward. So we have a spacecraft heading out to interstellar space heading south, that's Voyager 2, and one heading north toward interstellar space. In the next short sequence, we'll show you some of the things which we saw on this journey past the giant outer planets. First, there was Jupiter, the largest of the giant planets, the mystery of the Great Red Spot. What we discovered was it's a huge hurricane-like storm system 3 Earths across, but it's just one of many such storm systems. Saturn, we flew by Saturn's rings and discovered it's made up of countless particles of icy stuff, BBs, marbles, snowballs, some things as large as houses. On to Uranus, which is tipped on its side with its pole facing the sun, so it's like a target in the sky when we flew by in 1986. One of the major discoveries was the magnetic pole of Uranus is nearer its equator than its rotational axis. And of course, Earth, Jupiter, and Saturn, the magnetic pole is up where the rotation axis is. On to Neptune, the most remote giant planet, 30 times as far from the sun as the Earth. So cold we expect it to be very, very quiescent. But in fact, it has the fastest winds in the solar system, even though it has the least energy to drive the winds, and it had a great dark spot. So this journey was really just full of surprises as we learned things we didn't know were there to be learned. And there are two bookends which sort of illustrate that. The first bookend is Io, a moon of Jupiter. Until that time, the only active volcanoes known in the solar system were right here on Earth. But when we flew by Io, we discovered that there were 8 active volcanoes, some of them, as you can see, erupting hundreds of miles above the surface of this tiny little world. And the other bookend was the last body we visited, which is Triton. It's a Pluto-sized moon of Neptune, so cold, 390 degrees Fahrenheit below zero, that even the nitrogen forms the icy polar cap that you see. But those dark streaks of that icy polar cap are the deposits of geysers erupting at 390 degrees below zero on this icy world. Just an example of how remarkably diverse the bodies are in the solar system, familiar in form, but diverse in detail, and has really changed our whole view of the solar system in the textbooks which have been written since that time. But that was not the end of our journey of exploration. There was still the heliosphere. I can't show you a picture of the heliosphere, but I can show you a video of our kitchen sink. So if we could have the next video, because it is, you can see the heliosphere in it. Where the water hits the bottom of the sink, you notice the water is flowing radially outward very fast, just like the solar wind. But eventually it slows down, but it slows down abruptly in a shock and piles up and forms a thick ring of water. And it's in the thick ring that the water flows down the drain. That's exactly what's happening in our heliosphere. And if we could have the final graphic on this, you'll see that the two Voyager spacecraft are in the thick ring. They're in that region just on the whoops, that's not the video, but just on the outer edge of the bubble there, where they're about to break free of the solar system. This now is a computer graphic of this same story, where you can see the wind from the sun radially outward and then turning to flow down the tail. The tail is the drain. All of the solar wind has to go down the drain, which is the tail. Outside, in interstellar space, there's another wind which is coming and flowing around. This wind is slower. but it's still a very fast wind flowing around outside the heliosphere itself. So there's a separation between the inside and the outside. So what else is outside? What's outside is really the result of a cloud, which in the next graphic we can see the cloud, which is an artist's sketch of what we believe is outside by Frisch and Huff, based on data they've taken from Earth-based telescopes. And there's the sun. It's moving around the galaxy. And also there's this cloud, which has just enveloped the heliosphere about 100,000 years ago. That cloud was formed by the explosion of a number of nearby massive stars. 5 to 10 million years ago, they ejected most of their atmosphere and created these clouds. And that cloud is essentially moving and enveloping our solar system. So we are trying to get outside of our bubble into interstellar space to directly measure what is there. The next final slide I want to show is an example of what one of these things look like. This is actually a WISE image of an astrosphere. Around that star there's an invisible bubble you cannot see, but you can see where the interstellar wind is creating a bow shock in front of this thing that cannot be seen. We don't know how long, much longer it will take to get outside our bubble, but every 3 years, Voyager 1 travels 1 billion miles. So we shouldn't have too many more years to wait before we pass the next major milestone in this humanity's farthest journey. So now I'd like to turn this to Suzanne, who will talk more about the spacecraft.
Thank you, Ed. I want to tell you that it's a pleasure to be here to talk to you about Voyager today. Voyager was my first job. It has a young engineer, a younger engineer, coming out of college. I started as an engineer before the Uranus encounter, and I've come